Small disclaimer at the beginning, this kind of update is not like something with Java 8 or new version of Scala. You can switch to it right now. There is absolutely no risk. Your code will work no matter what. So what's new in Kotlin 1.3? Coroutines are stable. Probably you are already using coroutines. If no, you should try. They are not experimental right now. So what are coroutines? Coroutines are the way compiler can generate code for us, so we don't have to write this kind of callback hell, and we can just write like that, linear. The compiler will assure that everything is not blocking the UI thread or any IO threads, and everything is done pretty well. And coroutines library now hits 1.0. Kotlin X coroutines for many people means just the coroutines. It is a library that provides us with all that functionality like launch, async, await, and everything like that. Now, when it's 1.0, you don't have to write this experimental postfix in all these packages. You just can import things from Kotlin X coroutines packages. And Kotlin X coroutines 1.0 introduced concept of structured concurrency. As you probably know, coroutines aren't something that is new in programming. They were theorized and even done in some languages before. For example, Go have quite nice implementation of coroutines. But structured concurrency is something new introduced by Kotlin. What I mean by structured concurrency? In Go, launch comment that launches coroutine is somehow like go-to command from basic and similar languages. It just starts some part of the code in other thread, and you have to manually handle any errors, cancellings, and things like that. But and Kotlin was like that actually in 1.1 and 1.2, but in 1.3 we have structured concurrency. What does it mean? It means that coroutines are now scoped. So when every coroutine is working in some scope, there is a top-level global scope. When coroutine is working in some scope, when it crashes because of some networking issue or something like that, and its error is not handled by anything, it is propagated to parent scope, and parent scope is cancelled, and all children coroutines are cancelled. So here is the great example. We've got two resources loaded from some URLs, and in Go coroutines and coroutines before Kotlin 1.3, if something crashed during loading of the first resource, we are still trying to load the second resource, even though we have nothing to do with them, because we cannot just combine these resources. But in Kotlin 1.3, everything is enclosed in coroutine scope. So when the first loading process crashes, that all this scope is invalidated, and the second loading coroutine is cancelled. So it works just as we expect it to work. You don't need to manually set up this coroutine hierarchy or anything like that, because before, when you used experimental coroutines, it was quite tedious and generated a lot of boilerplate code. Now it is granted for free. Kotlin native hits 1.0, and Kotlin has new multi-platform project model. What does it mean? You can now develop applications for example, iOS and other native targets in Kotlin. You can even have just by including one Gradle plugin, set up multi-platform project. What it means, it is project that have a few modules. Some of these modules are so-called common modules, then can be referenced from any other module, and some of them are platform specifics. So for example, for iOS, for JVM, for Android, for JS, and whatever. This way, you can write multi-platform application with communication and business logic layer common to all this platform. You only write presenter code in platform-specific modules. What is more in Kotlin 1.3? There are two new experimental features. The first one is method contracts. As you probably know, Kotlin has something called smart casting. For example, this code works. Even though S is marked as new label string, compiler knows that if S was null, actually this line cannot be reached. So in this line, S is treated as a normal string, so you can call length method without problem. You don't have to use any conditional application like question mark dot operator or bank operators. It just works. Compiler no, it is not null label here. But until Kotlin 1.3, you cannot extract this condition to other function, because when you write code like that, compiler has no way to know that this in this line, this string is guaranteed to be non-nullable. So this code doesn't compile. It even doesn't compile now, but now you can write something like contract in the method. It is information for compiler. It is present nowhere in generated bytecode. It has no influence on behavior of this method, but this contract tells us if this method returns, so if it not throws any error, it implies that B, this predicate, is true. So this tells the compiler, in our example, that S is not null. So compiler now knows that you can call length without any problems, without any errors according to nullability. This is, of course, experimental feature. It will be improved in the next releases of Kotlin. Actually, now you have to pass special flag to compiler to enable this kind of behavior, or decorate every declaration method using this kind of contract and every method using this kind of contract with special annotation. I think it's experimental contracts or something like that. These contracts are stable for methods from standard library. So, for example, you can assert that string is not null using methods like is null or empty or something like that. It was missing in previous releases of Kotlin, but now there is here. It is, for now, the contracts are quite limited. You can only reason about nullability issues, about types of things passed to these methods, and you can assure compiler that some fragment of code is executed, for example, exactly once, or is called in place. The other experimental feature in Kotlin 1.3 are inline classes. It will be easy to explain this on example. Let's assume we have some applications that deals with distances, and user can provide distance in kilometers or in miles. We can keep them as plain or doubles, but our computations will be prone to errors, because we must be sure every time if this distance is kept in miles or kilometers. But we can declare this kind of wrappers, the classes accepting only one parameter, that is val. and we can mark them with inline keywords. What does it change? This class is now treated in generated bytecode, usually as just double. It has some type. So, for example, when we have function like this, set distance, that accept only kilometers, we cannot pass here miles or we cannot pass here double. But in compiled code, it is often represented as just double. The constructor of kilometers class is never invoked or anything like that. It is sometimes used as class when we, for example, need some polymorphic context or we use reflection. Then it actually will be created object of type kilometers, but those are rather rare cases in the good written code, well-written code. And it behaves exactly like a boxed and unboxed type in Java. For example, we can make some extension properties to this class. So in our example, we can have method that converts one type of inline class to the other. I want to remind one more time that this, in usual cases, has absolutely no overhead in runtime. So no new objects are created. It is just for compiler and lives in compile time. And this inline classes allows standard library to define unsigned types. So now we have unsigned integers, unsigned shorts, and other things like that in standard library. This both features inline classes and unsigned types are both experimental features, so we must enable them or by a flag passed to compiler or by a switch in Gradle build file. The one last change from Kotlin 1.3 that I like to point out is something with ergonomics of when expressions. When can now capture a value that it is evaluating. We can see it here. We've got some request data, and inside this when, it is assigned to value data. It is properly scoped, so it doesn't leak outside of this when. You can access it only in branches of the when. And Kotlin has smart casting, so it knows exactly what type it has. For example, in this branch, when we check is it int, it has this value has type int, and we can use it as int. In the string branch, this has type string, so we can use it as string. Yeah. So those are, I think, most important features of Kotlin 1.3. They are quite more small changes, especially in standard library, but this was not full changelog. I only wanted to give you a quick overview of the features. Thank you. So now I think we can start our Q&A.